Imagine you are standing at the edge of time itself, not metaphorically, literally. You are looking through the most powerful eye humanity has ever built. A golden mirror the size of a tennis court floating 1,000,000 miles from Earth in the cold silence of space. And what it shows you is impossible. 6 massive structures of light, older than anything should be. Galaxies the size of the Milky Way blazing with hundreds of billions of stars, sitting in a part of the universe where nothing that large should exist yet. Not in 100 million years, not in 500 million years. They are simply too old, too big, too perfect. And right now, no one on this planet can explain why they are there. Let that satisfying image sit with you for a second. Because what the James Webb Space Telescope has been sending back to Earth isn't just a collection of pretty photographs from the deep cosmos. It's evidence that our entire understanding of how the universe was born, how it grew, how it built everything you see around you, might be fundamentally terrifyingly wrong. It started beautifully. When Webb first opened its golden eye in mid-2022, the images were breathtaking. Nebulae draped in color like oil paintings. Star nurseries glowing in infrared light invisible to every telescope before it. Galaxies spiraling in the blackness like slow, ancient hurricanes made of fire. Scientists wept. The public shared the images millions of times. It felt like we had finally earned the right to see the universe as it truly is. But something was wrong. Not wrong in an obvious way, not wrong like a siren or a flashing red light. Wrong in the way that a doctor pauses too long before speaking. Wrong in the way a number on a screen makes a room full of the smartest people on Earth go silent. Deep inside those images, buried in the faint red glow at the very edges of the observable universe, researchers found something that didn't belong. Tiny dots, fuzzy reddish smudges of light that looked, at first glance, unremarkable. An astrophysicist named Erica Nelson at the University of Colorado was scanning one postage stamp-sized section of a Webb deep field image when she froze. The dots were too bright, too red. In astronomy, red light means old light. Light that has been stretched across billions of years of expanding space, pulled like taffy until its wavelength shifts from blue to red. And these dots were incredibly red, which meant they were incredibly far away, which meant they were incredibly old. But here's the problem. When Nelson and her international team ran the numbers, they realized these 6 objects weren't just old. They existed between 500 and 700 million years after the Big Bang. That's the cosmic equivalent of a newborn baby. The universe at that point was barely a toddler, still cooling from the primordial fire, still assembling its first atoms of hydrogen and helium into clumps. There should have been nothing there but small, chaotic clouds of gas. Maybe a few dim, infant galaxies struggling to form their first generation of stars. Instead, Webb found galaxies containing almost as many stars as the modern Milky Way, fully formed, structured, massive, as if someone had fast-forwarded the universe by billions of years and nobody noticed. And that's not even the worst part. Because the problem isn't just that these galaxies are big, it's that they shouldn't be physically possible. Under every model of cosmology that has ever been tested, confirmed, and trusted for decades, there simply was not enough normal matter in the early universe, not enough raw material, to build galaxies this massive, this quickly. Stars need gas to form. Gas needs gravity to collapse. Gravity needs time to work. And there was no time. 300 million years is a blink. The first stars hadn't even finished dying yet. The heavy elements that make planets, that make dust, that make you, they are forged inside the hearts of massive stars and scattered when those stars explode. Multiple generations of stars must live and die before a galaxy can look mature. And yet here was Webb, showing us galaxies that looked like they had already lived through billions of years of stellar evolution, sitting in an era when the universe had barely learned to breathe. But it gets worse. In mid-2025, Webb found something even more disturbing. A galaxy called JWST Z14-0, sitting at a redshift of 14.32, meaning its light comes from just 290 million years after the Big Bang, not 700 million, not 500 million, 290. That's roughly 2% of the universe's current age. And this galaxy wasn't just sitting there dimly, it was blazing, astonishingly luminous, just 1,600 light years across, tiny compared to the Milky Way's 100,000, but packed with stars burning so fiercely that their light has traveled over 13.5 billion years to reach us. And when scientists studied the spectrum of that ancient light, they found something that made the mystery infinitely deeper. Oxygen, not hydrogen, not helium. Oxygen, an element that can only be created when massive stars fuse lighter elements in their cores under unimaginable pressure and then explode in supernovae, seeding the surrounding space with heavier atoms. The presence of oxygen in a galaxy this young means multiple generations of massive stars had already been born, lived their entire lives, and died in spectacular explosions. All within a window of time so narrow that our physics says it cannot happen. And this is where things change. Because when one anomaly shows up, scientists can explain it away. A statistical fluke, a measurement error, a misidentified quasar. But Webb didn't find one impossible galaxy. It found dozens, then hundreds. Every time the telescope pointed deeper into the primordial darkness, it found more of them. Mature, massive, structured, chemically enriched galaxies in places where only infant chaos should exist. In early 2026, yet another one appeared. A dust-packed galaxy called EGS Z11R0, seen just 400 million years after the Big Bang, already looking far more evolved than any model predicted. Its size, its dust content, its internal structure, none of it fits. It's as if you discovered a skyscraper standing in a field where the concrete hadn't even been poured yet. Think about what that implies. Think about the violence required. Stars 10, 50, 100 times the mass of our sun. Born, burning through their nuclear fuel in just a few million years, detonating in supernovae powerful enough to seed surrounding gas clouds with oxygen, carbon, silicon. And then new stars forming from that enriched debris, and those stars dying too, and the cycle repeating again and again and again, all squeezed into a window shorter than the time it takes some stars in our own galaxy to complete a single orbit. The early universe wasn't empty and quiet. It was a catastrophe, a chain reaction of creation and annihilation, running at a speed that our equations say is impossible. So what does this mean? There are several possibilities, and none of them are comforting. The first is that star formation in the early universe was wildly, almost absurdly more efficient than we thought, that the first stars formed faster, burned hotter, died quicker, and recycled their material into new stars at a pace our simulations never imagined. If that's true, it means the early universe was a furnace of creation operating at maximum intensity, a cosmic forge running at speeds that border on the thermodynamically impossible. It would rewrite every textbook ever written about stellar evolution. But here's another possibility that keeps certain physicists awake at night. Some of these galaxies might not be galaxies at all. They could be something else entirely. Enormous black holes surrounded by superheated gas, devouring matter so violently that the friction and heat made them glow brighter than 1 trillion suns, disguised as galaxies, hiding in plain sight. A 2024 NASA study suggested exactly this, that some of Webb's impossible galaxies might actually host black holes, consuming gas at ferocious rates, making the objects appear far more massive than they truly are, which raises its own terrifying question, how did supermassive black holes form so early, so quickly, in a universe that had barely begun? And then there is the possibility that no one really wants to say out loud, the one that sits at the back of every cosmologist's mind like a shadow. What if our standard model of cosmology, the lambda CDM model, the framework that explains dark matter, dark energy, the expansion of the universe, the cosmic microwave background, the entire architecture of reality as we understand it, what if it's wrong, not slightly off, not in need of a tweak, but fundamentally, structurally incomplete in ways we haven't even begun to imagine? What if the universe didn't grow the way we think it did? What if the Big Bang wasn't what we think it was? What if the constants we've measured, the forces we've modeled, the timeline we've constructed, what if all of it is just an approximation of something far stranger, far more complex, and far more unknowable than human minds are built to comprehend? That is the real fear here. Not that we found some old galaxies, but that we might be standing at the edge of a